In this video for Math 94, we'll be looking at examples from homework number 4, covering sections 8.5 and 8.6. Topic is quadratic functions, finding solutions, numerically, graphically, and by factor. So, let's take a look at this following table. We're going to draw a little graph of this quadratic function. The function is f of x, I'll write it over here, equals x squared minus 4x plus 3. So if I plug negative 2 into this function, I get negative 2 squared, or 4, minus 4 times negative 2, so that's going to be plus 8. 4 plus 8 is 12, plus 3 is 15. So I'm going to say negative 2, 15, put a little drawing here. If I plug negative 1 in here, making this table work, I have negative 1 squared, which is 1, minus 4 times negative 1, which is plus 4, so that's 5, plus 3 is 8. Negative 1, 8, I kind of have to guess where that is, maybe about right here. 0, plug in 0, I get 0 squared minus 4 times 0 plus 3, which is just 3. Plug in 1, I get 1 squared minus 4 times 1, which is negative 3 plus 3, which is 0. Plug in 2, I get 4 squared minus 4 times 2, which is minus 4, plus 3 is negative 1. So maybe about right here. Plug in 3, I get 9 minus 12 plus 3, which gives me 0. Plug in 4, I get 16 minus 16 plus 3, which gives me 3. And plug in 5. With 5, I get 25 minus 20, which is 5 plus 3, which is 8. So just to emphasize here, I'm going to label these points. Minus 2, 15, negative 1, 8, 0, 3, 1, 0, 2, negative 1, 3, 0, 4, 3, and 5, 8. So if you look at this, you see that these points follow this pattern of a quadratic, as they should. And of course, this would continue as we go on in each direction. So let's use this table and this picture, this graph, to help us solve some problems. So here is a quadratic equation. We're going to solve x squared minus 4x minus 3 equals 8. Well, we can see from the table that the only difference between f of x equals x squared minus 4x plus 3 and this equation x squared minus 4x minus 3 equals 8 is f of x equals 8. So where does f of x equals 8? It equals 8 here and here, which is when x equals negative 1 and 5. Look at the picture. You can see when f of x equals 8 is when x equals negative 1 and x equals 5. Let's do another one here. Well, how about x squared minus 4x minus 3 equals 0? Again, this function right here is f of x. So if I take a look, I'm going to zoom out here a little. If I take a look at my table, and I look where is x squared minus 4x plus 3 equals 0. That happens here and here. And that happens when x equals 1 and x equals 3. Let's try a little bit harder problem. X squared minus 4x minus 3, I'll zoom out just a little bit more, equals 15. Well, again, we see that that gives me negative 2. But do you see that, remember, this pattern is going to continue. And here I went, as I moved from negative 2 to negative 1, I went from 15 to 8. And from negative 1 to 0, I went from 8 to 3. And from 0 to 1, I went from 3 to 0. And then from 1 to 2, I went from 0 to negative 1. But then I started going up again. And you remember that parabolas have this idea of symmetry here. So here we have 1 and 3 being symmetric. They both have answers of 0. and 0 and 4 being symmetric, they both have answers of 3, and negative 1 and 5 being symmetric, they both have answers of 8. So at negative 2, the answer is 15. So what would the answer be at 6? Well, by symmetry, it also has to be 15. So there's also the solution, even though it's not in the table, of 6. Now, that symmetry, when you draw this picture, gives you an idea that the axis of symmetry is right here. This point here, remember, is called the vertex. And this axis of symmetry is this line. That's the line that I could bend this over with and get exactly the same copy. Now, this is a vertical line, so it has the equation x equals, and x equals what? The x-coordinate is 2. So the axis of symmetry is x equals 2. Now, how about factoring the trinomial? Sure, you could take x squared minus 4x plus 3 and factor it the way you did in the previous couple of sections. However, let's think about this. If the x-intercepts are 1 and 3, then you know this has to factor into x minus 1 and x minus 3, because those are the two values that make this 0. Since the leading coefficient is 1, that gives me this is factored as x minus 1 times x minus 3. So this is a problem where we constructed a numerical table, we constructed a graph, and we used the table or the graph to help us solve these solutions. And sometimes that's useful. Let's try one, again, a little bit different here, a little bit harder actually. Let's take a look at this one. So I've filled in the table for you. Whoops, let's go zoom in a little bit. We have negative 1. If I place the value negative 1 in here, I will get that function. By the way, if you are interested in using your calculator to find this table of values, let me show you how to do that. Turn your calculator on, then hit the value y equals. Now clear out anything you have in y equals. Then go up here and place in the function, which is x squared minus 6x plus 5. Whoops, made a little mistake there. Notice when you have x squared, I should use my arrow to go down, back down here, and this is minus 6x plus 5. Okay? Now, if I want to make a table, notice my values of x's I'm using. I start at negative 1 and go to 6. So I'm going to hit second window, which gives me table set. And I'm going to start at negative 1, and I'm going to count by ones. So it's going to start at negative 1, then count by ones, and go up with x, each value of that. Then it's going to plug those into that. I'm going to leave independent and dependent as auto. Notice table is second graph. This gives me my table. So I have negative 1, 12, 0, 5, 1, 0, 2, negative 3, 3, negative 4, 4, negative 3, 5, 0. If you want to keep going, you'll see 6, 5. Now I'll put this off to the side. That's the same thing as if you were just calculating these by hand. Now, let me draw a quick graph here, just to get a visualization of what this will look like. So here's an xy coordinate system, and I'm going to start with x being negative 1, and I'm going to go up to 1, 2, 3, 4, 5, 6. Let's go one more just for good measure. And you'll notice this goes up to about 12 and down to about negative 4. So I'm going to count by threes again. Let's do 3, 6, 9, 12, minus 3 this way. You can choose any scale you like. So negative 1, 12 is this point right here. 0, 5, maybe about right there. 1, 0, 2, negative 3, 3, negative 4, maybe about right here. 4, negative 3, 5, 0, and 6, 5. Okay, so you can see again that this makes this nice parabola shape that we expect with our quadratics. So I'll just label these points again: minus 1, 12, 0, 5, 1, 0, 2, negative 3, what's that, negative 3, negative 4, 4, negative 3, 5, 0, and 6, 5. So you can see the symmetry in here. Right here is my axis symmetry. You can kind of get an idea of what that symmetry looks like. Now, let's solve this. Okay, solve this equation. X squared minus 6x plus 5 equals 12. Using a table, you'll notice there's a 12 right here, so certainly the example is -1. But this pattern continues, remember. We only have the table up to 6. What would the value be for 7? Well, by symmetry, I know this value for 7 has to be the same as the y value over here, so that would be 7, 12. So I also have the solution, 7, as a value for x there. What about x squared minus 6x plus 5 equals -3? Again, going to the table, we can see the answers are 2 and 4. Going to the graph, -3 down here, so we can see the answers are 2. Okay, if I go out here, 2 and 4. So my answers are 2 and 4. How about x squared plus 5x plus minus 6x plus 5 equals 12? Oh, I've already done that one, so I'll just write it down again. Here's an interesting problem. We'll kind of zoom out a little. X squared plus minus 6x plus 5 equals -6. Looking at the table, for -6, let's zoom out just a little bit more. Okay, for -6, looking at the table, I don't see a value of -6. But it's really clear on the graph that -6 be down here, right? There are no values where this graph is going to intersect that. Therefore, there's no solution to this. There's no values of x that give me an answer of -6. Now, factor the trinomial. It's easy enough to do by hand, but where is this 0? It's 0 at x equals 1 and 5. That tells me that x minus 1 and x minus 5 must be factors. And since the leading coefficient here is 1, this is my solution. This is my factorization. So you can get that from these tables and graphs also. Now, you've spent a lot of time the last few weeks factoring, and we're going to use this idea to help us solve some factoring problems. Now, to do this, we need something called the zero product principle. Now, what is a zero product principle, or a zero product rule? Zero product rule says if you have two numbers multiplied together and their answer is 0, then one of these, or both, have to equal 0. Now, notice this is only for multiplication, and if you think about this, if I multiply a bunch of numbers together and the answer is 0, the only way that can happen is if one of these is 0. This problem right here we could solve with a table or a graph. However, I think it might be easiest to solve this by factoring. Let's factor this. If I factor this, and I'm going to factor this the quick way, I know that this has to be x and x. And I'm looking for factors of 42, -42, that add up to -1. Well, the two numbers I can think of that that multiply together are 42, are 6 and 7. So I would mean -7, that would give me a -1, and +6. Now, if you look at this form of this equation, this is a product. If you read this, you see the quantity x plus 6 times the quantity x minus 7 equals 0. By the zero product rule, that means x plus 6 equals 0, or x minus 7 equals 0. Taking a moment, you can solve this, and that tells you that x equals -6. Taking a moment, you can solve this, and that tells you that x equals 7. So your solutions are -6 and 7. Okay? So what is the process that you go through here? To solve by factoring, number one, you have to make sure 0 is on one side of the equation. And then you should factor the trinomial. Now, I don't care what method you use to factor the trinomial. just factor the trinomial. Then set each factor equal to 0 and solve. So this is the process that we would use. Let's get a little harder. This one is a bit more difficult to do, and maybe I'll use my box method to factor. Oh, the first thing I should do is make sure that 0 is on one side of the equation. That is true over here. 0 is on one side of the equation. So I'm going to factor this trinomial by using the box method. Okay. I have 2x squared and negative 33. That's negative 66x squared if I multiply those two together. What are the factors of negative 66 that add up to positive 5? Well, the only factors I can think of negative 66 are 11 and 6. So I'm going to need a positive 11 and a negative 6. Looking across this row, I can factor out only an x. X times what is 2x squared? That's 2x. 2x times what is negative 6? That's minus 3. X times what is 11? That's plus 11. So this factors into 2x plus 11 times x minus 3 equals 0. That tells you 2x plus 11 equals 0, or x minus 3 equals 0, which tells you that 2x equals negative 11, or x equals negative 11 halves, or x equals 3. So there is your solution. Be careful. You can also factor other methods than just using the box. This is a binomial. Remember, with a binomial, it's either a difference of squares or a sum or difference of cubes. But the first question you should ask with any factoring problem is, can I factor anything out? And notice I can factor out a 2. Then what I have left over is a difference of squares. So that's x minus 3, x plus 3. So that tells you that x equals 3 or negative 3 is your possible solutions. Now remember, that first rule is to make sure you have 0 on one side of the equation. That comes up in this problem. This problem, it's very tempting to just start by factoring this. Don't do it. Make sure you have a 0 on one side of the equation. So I'm going to subtract x here. And I'm going to add 13. If I do that, I get 0 on the right-hand side of the equation, and I get 2x squared minus 16x. 19 and 13. What is 19 and 13? 19 plus 13 is going to give you 32. Okay, you might want to stop the video and see if you can factor this on your own. If you want to come back, the first thing I'll notice is that a 2 is in common here, so I can pull that out. That gives my life a lot easier. I will have x squared minus 8x plus 16. Okay. This tells you that this is x minus 4 times x minus 4. Okay, if you try to factor that. That gives you a solution of x equals 4. That's the only possible thing that's going to make this equal to 0. Now notice that occurs twice. This is called a double root. And it also comes from a perfect square trinomial. You might remember from your work with factoring that this can be written as 2 times x minus 4 quantity squared. That's where the word perfect square comes from to do that. Some of your problems in WebAssign ask you to identify this. If you have a double root, it came from a perfect square trinomial. Going back to the previous problem, this was what we called a difference of squares. How do you know you have a difference of squares? You know you have a difference of squares if your two answers you get are the same value but opposite in sign. These examples are neither a difference of squares nor a perfect square trinomial. So those are what you should pay attention to doing that. So that's a little bit about factoring and solutions. Now, what is the relationship between an x-intercept and solutions of a quadratic equation? Well, Here is a quadratic equation written in factored form. If I multiplied this all out, I would get 2x squared, let's see, plus minus 3x minus 2, which will look like a quadratic equation. To find the x-intercepts, you might remember that x-intercepts occur when y equals 0. So solving this is just setting y equal to 0. Well, if you look at this problem, you say, hey, wait a minute. That's just what I did up here. That tells you 2x plus 1 equals 0, or x minus 2 equals 0. So 2x equals negative 1, x equals negative 1/2, or x equals 2. So my two solutions to this quadratic equation are negative 1/2 and 2. But if I were to draw this graph, that would tell me that I cross the x-axis at negative 1/2 and at 2. So I cross the x-axis here. So the x-intercepts really are negative 1/2, 0, that ordered pair, and 2, 0, that ordered pair. So that's what we mean by the x-intercepts. So it's really very easy to find the x-intercepts. Let's take a look at this. So how would you name the x-intercepts of this? Remember, x-intercepts are when y equals 0. So I am going to set y equals 0 and just solve. If I set y equals 0 and solve, that tells me that 7x minus 8 equals 0, or 2x plus 3 equals 0. So 7x equals 8, x equals 8/7. Or, in this case, I'll subtract 3. 2x equals minus 3, and x equals minus 3/2. So my ordered pairs are 8/7, and minus 3/2. Okay, very easy to do. Why don't you try this one on your own? Okay, let's let y equal 0 again, x minus 4, and x plus 3. That tells you that x minus 4 equals 0, or x plus 3 equals 0, which tells you that x equals 4, or x equals negative 3. Now, since I'm looking for x-intercepts, I want to write these as ordered pairs, 4, 0, and negative 3, 0. Those are the places where you would cross the x-axis here. A couple other problems that come up have to do with the quadratic equation. Here's a question from WebAssign. Use the equation y equals a times the quantity x minus x1 times the quantity x minus x2 to write a quadratic equation through these points. This looks like a really difficult problem. But remember, this is not just an ordinary point. These 2 points happen to be x-intercepts. How do I know they're x-intercepts? I know they're x-intercepts because the y-coordinate is 0. So at negative 5, 0, and at 7, 0, these are x-intercepts. My other point is 3/16. So I'm looking for the quadratic equation that goes through these. Now, since I know that negative 5 and 7 are x-intercepts, I know that x has to equal negative 5 and x has to equal 7. So that tells you that x plus 5 equals 0, or x minus 7 equals 0, which is the same thing as saying this, x plus 5 times x minus 7. Now, the only thing that could be different is this constant in front of it, this number, because there are many parabolas that have x-intercepts negative 5 and 7. There could be ones going up, going down, going up sharply, going up narrowly. The only difference is there could be a number out there. So what I want to do is I want to use that other point I'm given to find this value of a. And the other point I'm given is 3/16. So when x equals 3, y equals 16. So let's plug that in. 3 plus 5 is 8. 3 minus 7 is negative 4. 8 times negative 4 is negative 32. So a is equal to negative a half if you solve that. That gives you the final equation, minus 1/2 x plus 5 x minus 7. Now, you're welcome to multiply this out. On the quiz, I would not mark it wrong if you left it in this form. So it asks you to write a quadratic equation in this form. A here is negative 1/2, and these are my two factors. Now, what was key to this problem is that these 2 points were x-intercepts. And you'll notice if the x-intercept is negative 5, then x plus 5 is your factor. And if the x-intercept is 7, then x minus 7 is your factor. So when I come to a problem like this, very much the same. I use this equation with these 3 points to find the quadratic equation through the points. I know that these 2 are x-intercepts. How again do I know they're x-intercepts? Because the y-coordinate is 0. Since they are x-intercepts, I can say my factors are x minus 10 and x minus 30. Both of these were positive numbers. These are the values that would make that 0. I'm going to multiply by a. To find a, I just need to plug in this point. So 18 equals a 20 minus 10 times 20 minus 30. If you do the arithmetic, that's 18 equals a. This is 10 times negative 10, that's negative 100. So a equals 18 over negative 100. So what is a way we can reduce 18 over 100? Sure, you can reduce 18 over 100 and get 9/50ths, so that's negative 9/50ths. So your final answer would be y equals 9/50ths, x minus 10, x minus 30. And again, you can multiply that out or leave that way. Okay, let's do one last thing, and that is we're going to take a look at some general forms of the quadratic equation. Y equals ax squared plus bx plus c. That's a quadratic function. And I'm going to use my calculator here to graph some of these for you to give you an idea of what these a, b, and c's really do here. So let's go to my graphing calculator, and I'll clear out everything. And I'm going to put in here x squared. And then I'm going to graph 2x squared. And then I'm going to graph 4x squared. And I'm just going to graph these on a standard window. So I'm going to hit zoom number 6. There's x squared. There's 2x squared. And there's 4x squared. You notice that as that coefficient of x squared gets larger, these go up faster. You might say they get steeper. To throw into this, I'm also going to throw in the equation minus x squared, okay? And also 1/2, I'm going to use 0.5, that's the same as 1/2, x squared. And 1/6, I'm going to take 1 divided by 6 times x squared. And I'm going to graph all of these and try to see what that is doing. Now, one of the things you can do on your calculator is you can turn equations off so they won't graph. I'm going to graph x squared, but I'm going to turn 2x squared off and 4x squared off and just leave these ones that I haven't looked at on. I have a window I want, so I'm going to hit graph. There's x squared. What's minus x squared? Okay, minus x squared, flip this over. And notice 1/2 x squared is a little bit fatter, a little less steep, narrow, if you want to say a little less steep than x squared, and 1/6 x squared is even less steep. The way to summarize this is as follows. In a quadratic equation, if a is positive, the quadratic equation points up. If a is greater than 1, then it's steeper than x squared. If a is between 0 and 1, then it's less steep than x squared. And if a is less than 0, it points down. So I want to graph these now, and let's take a look at what this does. So that a determines whether this points up or down. If it's positive, it points up. If it's negative, it points down. If it's greater than 1, it's going to go up steeper than x squared. If it's less than 1, between 1 and 0, it's going to go up a little less steep than x squared. And if it's negative, it's going to point down. So let's go back to my graphing calculator and let's try some more of these. So I'm going to try to figure out what the c does. So I'm going to hit y equals. I'm going to keep x squared there, and I'm going to clear out y2, y3, y4, y5, y6. I'm going to clear out all of those, and I'm going to put some of these in here. X squared plus 3. Whoops, I did that again. Okay, got to make sure I don't put that in the exponent. X squared minus 1. X squared plus 2. X squared minus 3. And x squared plus 1. Okay, just about done there. Now, I'm going to turn off all the ones that have negative numbers. So I'm going to turn off the negative 1 and the negative 3, and that should be good. So what I have graphing here is x squared plus 1, x squared plus 2, x squared plus 3, and x squared. So let's go to my graph. There's x squared. Here's x squared plus 3. Here's x squared plus 2. Here's x squared plus 1. So what did this number 3, 2, and 1 do? It made a vertical shift. So that number c there in my quadratic equation going up here seems to make a vertical shift right there. Now, let's go back to y equals. Let's turn off these. Let's see what happens if I turn on the ones that are negative. Okay, so make sure I turn off all the positive ones, turn on the ones that are negative, and I hit graph. There's x squared minus 1, x squared minus 3. So what happened? This moved this down. Not only does this shift happen, but it turns out that that value c right there is actually the y-intercept. You can use these two facts, this information about A and this information about C, to help you solve some problems. Let's take a look at this problem from WebAssign. I'll try to zoom in a little so you can see it. Use the properties parameters A and C to sketch the graph of the equation. Selected factoring to find x-intercepts may be helpful. No calculators. Of course, we can't tell you not to use a calculator, but let's see if we can do this. We're trying to look for a graph of y equals 3x squared. Well, let's look at my possibilities. Well, here I have 4 possibilities, right? I have these two, and you'll notice that these two point up and these two point down. What is, in my quadratic equation, ax squared plus bx plus c, what is a here? A is equal to 3, and you'll notice that that is positive. So you know it's not this one, and it's not this one, so it has to be one of these. Now, which of these would be 3 times x squared? Remember, regular x squared looks something like this. It goes through 0, 0, and then it goes through the point 1, 1, and negative 1, 1, and 2, 4, and negative 2, 4. So x squared looks something like what I've drawn dotted here. I'll draw that over here also for emphasis. 1, 1, negative 1, 1, 2, 4, and negative 2, 4, and goes through 0, 0. Now, which of these would be most likely to be the answer when a equals 3? Since 3 is bigger than 1, this should go up faster, should be a little narrower, go up steeper than x squared. So my answer is this one right here. This is the answer right here. So that's using just those little facts about A and C. Let's take a look at this one. This is a little different. Use properties parameters A and C to sketch the graph of this equation. Selected factoring to find x-intercepts may be helpful. No calculators. Well, the first thing you'll notice here is that a is -1. So what does that mean? That means you're pointing down. So you can't be this one, and you can't be this one. So you're either going to be this or this. Now, what is this business about x-intercepts? Well, remember, x-intercepts are where y equals 0. And if I take this and I solve, factor out a minus x, my two x-intercepts are at x equals 0 and at x equals 5. Which one of these has x-intercepts at x equals 0 and x equals 5? Right here and here. So this has to be my solution. This has to be my answer. This one has x-intercepts that looks somewhere around 2 and -2, so that can't possibly be correct. Let's see if we can figure this one out on our own. Which of these equations represents y equals 1/5 x squared minus 3? Okay, the first thing you'll notice is that a equals 1/5. That's greater than 0, so that means you point up. So you can't be this one or this one, right? Now, 1/5 is less than 1, so it should be less steep than x squared. Furthermore, I notice that c is -3, so that means that 0, -3 is my y-intercept. So this is 0, -3. This, by the way, is 0, -3 also. So the only possible answer is this one right here. So this right here is my answer. I hope you found this video useful.